Hey friends, this is an interesting question about polynomial factorization, which was in an Indian regional math Olympiad in the year 2013. Let's take a look at it. The question is, prove that the polynomial fx equals x to the power 4 plus 26x cubed plus 52x squared plus 78x plus 1989 cannot be expressed as a product fx equals px times qx, where px and qx are both polynomials with integral coefficients and with degrees less than 4. Fx has a degree of 4 here. That means there are two ways in which fx can be factored into two polynomials, each with degrees less than 4. Either one of them can be a polynomial with 1 degree and the other one can be a polynomial with 3 degree, or both of them can be 2 degree polynomials. So let us define two cases. Either fx is ax plus b times px cubed plus qx squared plus rx plus s, where ax plus b is the 1 degree polynomial and px cubed plus qx squared plus rx plus s is the 3 degree polynomial. Or fx can be ax squared plus bx plus c times px squared plus qx plus r, and both of these are 2 degree polynomials here. Remember that the coefficients a, b, c, p, q, r and s are integers here. We'll start with trying to figure out the leading coefficients, that is a and p. Notice that in both the cases the leading coefficient is the coefficient of x to the power 4, which is generated by multiplying the leading coefficients of the two factors. Also notice that the leading coefficient in fx is 1. So a times p can be equal to 1 only if a times a is equal to p is equal to 1, or a is equal to p is equal to negative 1. We can ignore the a equals p equals negative 1 case because that will just lead to factors which are negative of the ones found with a equals p equals 1. So let us set the leading coefficients a and p equal to 1 in both cases. Let us first focus on the option 1 here. First, we will expand the factors so the equation becomes fx equals x to the power 4 plus b plus qx cubed plus r plus b times qx squared plus s plus b times rx plus b times s. We can compare the coefficients of each term on both sides and get the following relationships. Comparing coefficients of x cubed, we get b plus q is 26. Comparing coefficients of x squared, we get r plus b times q is 52. Comparing coefficients of x, we get s plus b times r is 78, and comparing coefficients of the constant, we get b times s is 1989. Rather than finding the values of the variables here, we will try to analyze and see if the equations are actually solvable or not. There is something interesting about the numbers 26, 52, 78 and 1989 here. Can you think about what is common between these numbers? That's right, all these numbers are multiples of 13. The factorization of these numbers is 26 is 13 times 2, 52 is 13 times 4, 78 is 13 times 6, and 1989 is 13 times 17 times 9. Let's rewrite our relationships using the factorizations, and now we will analyze these four relationships through two separate cases. Case number 1 is that we assume s is divisible by 13. One of the implications of this would be that b cannot be divisible by 13. This is because the product of b and s is 1989, which is divisible by 13 but not 13 square, and s is already divisible by 13, so b cannot be. Another thing we can deduce is that r will also be divisible by 13. This is because s plus b times r is 78, which is divisible by 13. And we have already assumed that s is divisible by 13. This means that b times r should also be divisible by 13, which means at least one of b or r should be divisible by 13. As b is not, that means r has to be divisible by 13. Also, q is divisible by 13. This is because r plus b times q, which is 52, is divisible by 13, and 13 also divides r. This means b times q should also be divisible by 13. But as b is not divisible by 13, it means that q has to be. According to our findings, b is not divisible by 13, whereas q is. This is not possible because b plus q is 26, which is divisible by 13. This is not possible. This proves that our assumption that S is divisible by 13 is wrong. Now let's move to the case number 2 and analyze the case where S is not divisible by 13. We can deduce that B has to be divisible by 13. This is because B times S is 1989 and that is a multiple of 13. We have already assumed that S is not divisible by 13, so that means that B has to be. This also means that B times R is divisible by 13. This means that S plus B times R is not divisible by 13. This is because S is not divisible by 13, whereas BR is. But we already know that the value of S plus B times R is 78, which is clearly divisible by 13. And this is contradictory to our finding. That proves that our assumption that S is not divisible by 13 is also wrong. This proves that in any case, fx cannot be factorized into a polynomial of degree 3 and 1. Now we will use the same line of reasoning to check if fx can be factorized into a polynomial of degree 2 and 2. We will follow the same process where we first expand the factors into fx being x to the power 4 plus b plus q x cube plus r plus b times q plus c x square plus b times r plus c times q x plus c times r. Now we will compare the coefficients on both sides of this equation. On comparing the coefficients of x cube, we get b plus q is 26. Similarly, comparing the coefficients of x square, we get r plus b times q plus c is 52. Comparing the coefficients of x, we get b times r plus c times q is 78. And doing the same for the constants, we get c times r is 1989. In order to analyze these relationships, we will again break our analysis into two cases, where the first case is that we assume that C is divisible by 13. We can deduce that R is not divisible by 13, and this is because the product of C and R is 1989, which is a multiple of 13. As C is not divisible by 13, R has to be. We can also deduce that B is divisible by 13. This is because B times R plus C times Q is 78, which is a multiple of 13. And C is also a multiple of 13. This means that at least one of B or R has to be divisible by 13. As R is not, that means B has to be a multiple of 13. Using the findings till now, we can deduce that R plus B times Q plus C should not be divisible by 13. This is because C and B are divisible by 13, but R is not. This is contradictory to the information that R plus B times Q plus C has a value of 52, which is clearly a multiple of 13. This proves that our assumption that C is not divisible by 13 is wrong. Now we will come to the last case and assume that C is not divisible by 13. This means that R has to be divisible by 13, and this comes from the same line of logic that because R times C is 1989, which is a multiple of 13, and R has to be divisible by 13 because C is not. We can also deduce that Q is divisible by 13. This is due to the fact that 13 divides B times R plus C times Q, which has a value of 78. And 13 also divides R. That means 13 should divide at least one of C or Q. As 13 does not divide C, that means 13 has to divide Q. So Q is divisible by 13. Another thing we can deduce is that B is divisible by 13 also, because B plus Q is 26, which is a multiple of 13, and as Q is already divisible by 13, B also has to be divisible by 13. Based on our findings, we can clearly see that 13 does not divide R plus B times Q plus C. This is because R, B, and Q are divisible by 13, but C is not. This is contradictory to the information that R plus BQ plus C is actually 52. This proves that our second assumption that 13 does not divide C is also wrong. So we have proven that fx cannot be broken into two polynomial factors each of degree 2. And with this, we have also proven that fx cannot be written as px times qx, where px and qx are polynomials with degree less than 4. I hope that this solution was helpful for you and also fun to watch. Please like this video if you liked watching it, and comment on it with questions you would like me to solve on this channel. You can also subscribe to the channel to see more such videos, and thanks again.